Hi, in this video we're going to solve a pretty simple little equation here, x plus 3 equals 7. And you might even already know the solution to that, which is great if you do. But what I'm going to show you how to do is how to solve it with algebra tiles and how to solve it with written algebra. Alright, so on the left side I'll do my algebra tiles, and on the right side I'll write some algebra. You don't need to have this, but I like to draw a little balance here. Because the balance with the algebra tiles reminds me that when I say that two things are equal to each other, that means that they're the same. And this really reminds me that if I'm going to keep my equation balanced or keep the things equal to each other, then I need to do the same to both sides. So I like to draw a little scale there. You don't need to. So x plus 3, I'm going to put my x tile on and my 3 unit tiles. Now, different people's algebra tiles look different. I have a little key here. So for me, for what I'm doing today, I'm going to say that if I'm using negatives, I'll use red. And we don't have any negatives in this problem, so I won't use any red. I'll use just whatever my other side is, which with this set of algebra tiles is kind of green and beige-ish. Okay. So over here we have an x and 3 more, so x plus 3. And over here we have 7. If you'd like to line them up, feel free. And over on the right side, I'm going to write x plus 3 equals 7. So I've just copied my equation there. All right, so our goal with the algebra tiles is to get x all alone on one side of the balance and to see what it balances out to on the other. With the algebra, the written algebra, our goal is also to get x all alone on one side of the equal sign and to see what it's equal to, what it's the same as. So if we have x plus 3, we need to get rid of these extra 3's. So we'd like to take away 3, which we can definitely do. We can subtract 3. And the only rule is that we have to do also subtract 3 to the other side. We're going to do the same thing to both sides of the equation, or both sides of the balance. So I encourage people with algebra tiles to do, if you're going to take something away or add something, do it at exactly the same time on both sides, one with each hand. Because otherwise, sometimes when things get more complicated, you can kind of get mixed up with what you're doing. So there we go, we subtracted 3. Okay, now we're going to write the same thing down with our written algebra here. So the first thing that we're going to do is we're going to copy exactly what we had. We had x plus 3 equals 7. And then I'm going to write down what we did, which was we subtracted 3. If you happen to have another color, I think it's a nice idea to write the action that you're taking in another color because it makes it a little bit easier to compare both sides and just double check that you did the same thing on both sides. All right, now we just can write down what we have. Over here we have x, and it's equal to 4. And here x plus 3 minus 3 is equal to x, like we saw. So x. And over here we have our 4, and here you can compare 7, take away 3 is 4. So it's a pretty simple equation to solve, but I just want you to sort of pay attention to how we can write down the action that we took, and also sort of how we can represent that with algebra tiles. We are going to do a quick check, and this again really I'm showing you more so that you learn how to check it, because you probably already knew that the solution was going to be 4. So we're going to copy down the equation again. X plus 3 equals 7. And maybe I'll just use my purple marker here. So that x, I'm going to replace that with my solution. I think the solution is x equals 3. So I'll ask myself, is 4 plus 3 equal to 7? And yeah, of course it is. Yes. So that means that the equation is true if we replace x with 4. So x equals 4 is a solution to the equation we were given. X plus 3 equals 7. All right, so that was a pretty easy example of how to solve a little equation, both with algebra tiles and with written algebra. Thanks.